Hi everyone, let's take a chance to talk about Altair, our visualization tool in Python. And this is going to be an intro to Altair and what it's all about. So the core idea of Altair. The core idea is that visualization concepts should map directly to the implementation. So the way in which we think about and design visualization should be reflected in the way we code it up. Some would call this a grammar of graphics, and I think that would be kind of the core idea here. The idea behind that, right, is that if we have a good implementation, then that allows us to conceptualize well. So if the way we're writing down code aligns with the way that we're thinking about and designing visualization, then we can actually make better choices and iterate more quickly as well. The implementation in the grammar that we're going to try to reflect is that which we've also seen in Tamara Munzner's framework, the what, why, how framework, where we're mapping in the how we're using visual encoding channels and marks to map particular data attributes onto a visual form. Before we get too deeply into what Altair is, I want to contrast that first with a tool that's more familiar. So that tool is Matplotlib. I'm hoping that most of you all have seen Matplotlib. If not, I'll show you what some example pieces look like. Matplotlib is the maybe still the canonical tool for plotting in Python. Let's run through what some of the pros and cons of it are. First, if you haven't seen Matplotlib before, this is what a Matplotlib plot looks like. The PyPlot interface is designed to look a lot like MATLAB. We can go ahead and import that. It's a higher level plotting. Matplotlib actually has 3 internal levels that you can deal with graphics. The highest is the most abstract is this PyPlot interface. And then also we'll import numpy for some data, so import numpy as MP, and then define some random x and y values, and color is just going to actually be linear from 0 to 1,000 here. I think I'll actually do 1 to 1,000 or 0 to 9,999. And if we go and do a plot scatter on Matplotlib, it's actually just plot.scatter, x, y, and color. So the scatter, that's a high-level chart that's built in Matplotlib, and this was pretty easy. We built a scatter plot pretty easily. We added a color bar pretty easy. Okay, not really too much to complain about here, maybe. So some of the strengths for Matplotlib. The first is it was designed like MATLAB. Switching was and is easy. I got my start doing computation in MATLAB and actually made the same switch. When I moved to Python, I was using Matplotlib. There's a lot of different options for doing rendering backends. There's a lot of ways you can build a graphic out. You can build it into a PDF, you can build it into an SVG, a PostScript, a PS, AG is one of the PNG renderers that lives underneath it. So Matplotlib interface is at the low level with all of these different backends. So there's a lot there. In Matplotlib, you can make about any plot you want. Here's just a few examples of really different types of charts that were built in Matplotlib from their gallery. It might take some work, and you might be doing some of it, quote unquote, manually, doing some of the mapping. But you can build just about anything in Matplotlib, and people have. You can get really far in it. And for a while, right, it was the only tool, and it has been the standard tool for a long time. So since 2003, this has been the go-to Python plotting tool. It's well tested. It's a standard tool. Okay, so we're going to talk about Altair, but what doesn't MATLAB give us? Why might we want to move on from Matplotlib? Just first, before we get to some of the weaknesses, the gallery. So just to again say that you can build just about anything in this. You've got a shaded Mandelbrot set. You've got 3D graphics. You can build animated graphics. One of my favorite packages, add-ons to Matplotlib, is the XKCD package, which will add some jitter to all of your lines and switch your fonts to Comic Sans. So that's a one-line XKCD replication. So there's a lot of stuff here. Okay, but what are some of the weaknesses? Why might we want to choose a different tool? So first, it's designed like MATLAB. I'm just kidding. That's not necessarily a weakness. But these do fall out of that design. The API is imperative, right? And it's often overly verbose. So what do I mean by imperative? Right, and I'll show you some examples of what more complex plots look like in Matplotlib. This just means that when we want to go and plot something, we're telling Matplotlib how we want it to plot it. So like, for example, we'd say, go and draw some circles, put them here, and give them this color, right? We're not talking about the data, right? We're really talking about how to build the plots. We're dealing with the details of the plotting. And one of the other weaknesses is, right, there's no support for interactive web graphics. There is a library, MPLD3, where you can kind of take that low-level representation of a graph in Matplotlib and rip it out and try to replot it in D3. But then, you know, it's not very extensible. You get code that's auto-generated, and it's really hard to work with. So really, there isn't a great support here for making web graphics. You can make nice PDFs, but now as things are moving to the web, right, there's not a lot of support for this. So again, here is the Matplotlib plot we saw, and right, again, right, this is what I mean by its imperative, right? We're telling it to do a scatter plot and giving it the color specifically. So we're giving for all the circles the X and Y position and the color that we'll give to them, right? Not a whole lot about our data here. If we want to go and plot something that's from a data set, something that's in a data frame, and we want to do some, quote unquote statistical visualization, we might have data that's in a tidy format, right? This is a column oriented format where each row is a sample, each row is a flower here, and the columns are features, right? So each feature. So here, right, if we want to go ahead and use this in Matplotlib, right, we can. So this is what it looks like on the left, right? We have the plot or the code, and the right we have the plot. So here we've done a scatter plot, we've colored by the species. So what we actually had to do this, right, is we had to go and map these colors to each of the species. So you can see this actually zipped those together, right? So this was created a lookup for us between the species and the color. And then we actually had to group by and loop over. So if we loop over the group by object in pandas, then we go and create a separate plot. So we do a separate plot for each of those groups, giving them that color. So color map the species, right? That's going to be the key on this group by. So that's actually just a lookup. It's just a dictionary. And then we've gone ahead and done it, right? And then we've gone ahead and added a legend, right? And that's really how we did it. The legend was pretty easy, X and Y label, right? But you can see, we had to loop over each data element. So again, this is imperative. What it means is that to make this plot, we're having to go and tell Matplotlib how to draw it. Like if we know in our head we want circles with these colors, we can draw it, right? We can make it happen. But again, we're having to, use Matplotlib to actually just draw it. The things that weren't really clear in our code here is what is the data? So as we're looping over this, we have this group by object. It's not exactly clear which columns of the data are mapping to which visual elements. What is the transformation we did? What visual mark are we doing? So we didn't say that, right? We didn't actually explicitly say what the mark was. Our encoding channels, it's a scatter plot, so using X and Y. But again, we didn't say that. And scales and guides, right? We weren't too explicit on any of these choices. So these are all done implicitly by the scatter when we did that. If we want to go one step further in Matplotlib, if we want to go ahead and instead of plot them all on the same graph with different colors, right? If we want to go ahead and facet, right? So what we want to do here is we want to take one attribute of the data, which is the species, and use that to facet on X. Again, we can do this, right? Plot up subplots. You can go pretty crazy with this and build lots of sub panels in a graphic. Here we have the same color map. We define the number of panels to be that length. So it's the length of our group by. And here, instead of doing the same plot.scatter, right, we're actually grabbing one of those axes objects from that was returned by plot.subplots. We have 3 of them here, and I think we have 3. It's a 1 by 3, so down 1 across 3 grid, and then we're going to go ahead and do that scatter plot within each of those axes objects. right? So again, yeah, we've done it, and it's a little clear, but if I was asking, what did we use to facet on? So let's see, we did end panels, length of color map, so species.unique, so we faceted on the species. Right, you can see that, but it's actually not how we built the plot, right? We had to go ahead again and build it. Okay, so that's Matplotlib. And the problem here, the problem that we want to solve is we're mixing the what with the how. So the what, right, is the data, and the how is the actual encodings and marks and channels that we're going to use to build the graphic. So if we want a declarative visualization, a real grammar of graphics, we're going to go towards something that's declarative instead of imperative. So here, right, in an imperative framework, right, we're specifying how something should be done, right? This would be the scatter plot. Declarative, we're specifying what should be done. Imperative, specification, and execution, they're intertwined, right? And as we saw in that faceting example, right, the way in which we pull out the species and loop through, that's all intertwined with the plotting. So we're doing the plotting within a loop. So, that loop, I think, is a good example of where we've done the specification and the actual execution of it are all gumbled up. So declarative, right, we wouldn't have to do that, right? We want to actually specify the graphic, and that'll be separate from how it gets executed. And really, and I think I said this example earlier, the one thing you could remember about this is for an imperative, it's put a red circle here and a blue circle here, right? And that's what we just saw in Matplotlib. But really, in a declarative visualization, we want to map to a position and to a color. So we want to take specific parts of the data and map those to X and Y position, and we want to use a specific data element to facet, a specific data element to color. So, right, declarative visualization is going to let us think about the data and the relationships and the encodings and channels that we make, rather than the details of how we're going to build that plot. So if I think of a plot, and I can think of how to build it in Matplotlib, right? But that's not what we need to be thinking about, right? We want to be thinking about the data and how we're encoding it. And that's going to allow us, in this framework to do a better job making choices. So what does that look like? So Altair, right? Altair is the library for doing declarative visualization in Python. It's built on top of Vega and Vega Lite, and I guess also on top of D3. So there's a kind of a 3-layer sandwich under Altair. The lowest is D3, Vega builds on D3, Vega Lite builds on Vega, and then Altair builds on top of that. And I'll give an example of what plots look like in each of these. So in Vega, right, in Altair, this is Altair's gallery. So you can see all the different charts that are possible for building in Altair. There's a lot of different things here, and right, this is all of them. So you can see some violin plots down here. In the middle, here's some maps, a lot of different mapping stuff we can do. And all sorts of different faceting, different stacking, different detail and color use. And in all these, right, my mind is jumping to the encodings that have been made. So here we've mapped data to X position, to Y position, right? And by doing that, right, we can build all sorts of different graphs. I even see some ISO type graphs in here. So these are all the different things you could build in Altair. And really the answer is, you could build anything. So what does this look like? So let's take the same plot that we did in Matplotlib before, and here's what it looks like in Altair. So import Altair as alt, Vega datasets as data. This is the whole thing. We didn't preload the data, and here, right, we're going to specify the encodings directly. So mark point. So we're going to use a point to encode them. We're going to use a point as the mark, as the channel, and then our encoding channels are going to be X, Y, and color. So X is petal width, Y is sepal width, and color is species. That's it, right? So to do the color, all we had to say is take the data element, take the data for species, map that to color, right? Done. We got the plot. So this is mapping from the data to the visualization directly. So we'll dive into that one a little bit more detail, line by line, in a bit. And so these encodings are also flexible. So here we saw the faceting was a lot of work in Matplotlib. Again, here we can do this in one line. So column is species. So we're actually going to split by column on X in species. Right, pretty straightforward. And then one of the other things we mentioned is transitioning to the web. So here, right, Altair, to add an interactive, you just do dot interactive, right? And that's going to allow you to, in this case, zoom in and pan and drag on this graphic. Right, you can specify tooltips as well and build a fully interactive graphic. Again, that's because it relies on these JavaScript libraries under the hood. So there's actually mapping down to JavaScript at the bottom in a clean way, sitting on top of these frameworks. So if we want to dive into this first chart in detail, first, right, the alt.chart of iris. So here, right, we're taking tabular, really here is a pandas data frame. We're taking that and putting it into the chart. Right, we can use pandas data frames, CSV, TSV, JSON URLs. Altair supports URLs through Vega Lite supporting URLs of data. It can understand any of those formats. If it's a pandas data frame, right, I think Altair is actually going to go and convert that to JSON for us on the internal. So the first thing to do is alt.chart of your data. Right, here a data frame, we'll probably be working with data frames. The next is using the mark. Right, so mark point. Here, this is where you can think about what do you actually want to draw, and there's a lot of different choices that Altair provides for us: point, line, bar, area, rect, etc. And these are the primitives which we'll build out really any type of graphic, right? GeoShape if you want to do a choropleth. And the encodings are the next part. So what we're doing is we're mapping visual channels to the data columns. So you can specify the data type. So here, right, species n. So we're telling it that species is nominal. So it's what that is going to do is give it it's going to choose a nominal color scale. If we told it, for example, that it was ordinal, which wouldn't make much sense here. But if it was like salary range, right? Those have a natural order, and we could give it an O for an ordered data column and data type, and that would choose a color scale that is actually a ordered color scale. Here, it chose the color hue, but you might want to choose the saturation or lightness, right? Those would be better for a ordinal data set. So we'll make those choices for us. And then there's a lot of different positions, and these positions depend upon the mark as well. So I guess some of them are specific, but in general you have all of these channels to map every data element onto. So here, right, there's also detail I don't see there. This is just for the mark point that are available, I think, and it's going to depend on what mark you choose to have different channels available. But here, right, we can take any data column. Here we have, I think, 4 columns, and we choose which channel we want to map those to. So we could build out a lot of different graphics just by swapping those out. Now, if you want to think about how to go back to Matplotlib or any imperative graphing library, right, we could go and build out any of these different channels, right? But we'd have to think about how to build the chart quite a bit differently. If we break down the chart, we didn't do this to JSON in our actual example before, right? I don't think we did, right? We didn't because the chart actually got spat out. To JSON, right? That's actually going to give us just the Vega Lite spec for the chart. So really, all Altair is doing is taking what we've just specified in Python and mapping that down to JSON, and that JSON is read and rendered by Vega Lite, which again sits on top of Vega, which will render with D3 under the hood. And what this looks like for this particular graph, right? It'll stuff the data in as a JSON, like I mentioned, and then for the encoding, right? It's this simple in Vega Lite. So this is the Vega Lite spec. If you wanted to write this spec by hand, of course you could, right? And focus on Vega Lite. But Altair, will go ahead and do this for us. So it's a little bit higher level even than Vega Lite. So you can see that the data type is required in Vega Lite. If you don't pass it in Altair will fill it in for you a lot of the time. If it's ambiguous, it's a lot better to pass it in. And in this case, yeah, color XY and then mark point, right? That's really all there is to it. So I want to run through just a handful of examples. So here, right, same idea of a chart we just made, right? We have a nominal color and we have quantitatives on X and Y. You can actually see here it didn't pass in the data type, right? That was inferred by Altair. Another example, right, we can use a different row. So we can facet on Y using row, whereas we facet on X using column. And right, this uses still in the same, I think, same X and Y and color encoding as before. Right, to do something a little bit different, we can choose a different mark. So if we do mark bar, one of the options is how to stack them. So this will actually normalize the stacking, give it color, X and Y. So here, right, X summed up the quantitative. So it actually is a star quantitative, and it aggregated on the count. So here, we would pass in the full data frame, and the actual work to aggregate this would be done on the Vega Lite side, right? Again, this is actually still just building out the spec. It's not doing any work on our data, but right, this allows us to really quickly build a chart that would be a lot more complicated in any other language. We're stacking, right? And for X, that's going to be our position. Cool. Here's a different one, right? And, of course, here's just a stacked bar chart, right? We didn't pass the normalize. We could have, right? We didn't normalize it. Here, right, we actually used binning. So we did an automatic bin on X. So X, right, was a quantitative data type that we passed in. It'll be inferred as quantitative again, right? But we can go ahead and bin it. It's the same X position that same X that we'd specified before, miles per gallon, right? But by binning it, we get a really different chart. Yeah, that's what it looks like. So you can do these transformations, aggregations, and bin within Altair directly. You could also do them in pandas beforehand, but here there's no need, right? You can actually do those aggregations on the fly in Altair and then in Vega Lite. Here's another one, right? This is a marked text where we're coloring the background. So really, right, we're building out a table. We can do row, column, color, and actually say what the text is. So here we've, again, done an aggregation, right? So we've told it row and column are both ordinal. I guess row being ordinal doesn't make a lot of sense, but you can see it actually did order them alphabetically because we told it was ordinal. For cylinders, yeah, of course it's ordinal, so it'd be good to give that an ordinal type. Yeah, and so again, right, we can build out just a different type of chart. And I think I have a couple more. So let's run through. So here, right, mark line, we can build a line chart. Again, pretty simple, right? Not a lot we had to change from before. One other thing that's being showed off here, right, is the time data type. So it can understand times. That's the T. So we saw, I think, N, O, Q, and T. Those are the different data types that we can use. And this is the kind of chart that's actually a lot harder to build out in even something like Matplotlib, right, is actually working with geographic data. It's always been a weak spot. And this is really a strength of the technologies that underlie Altair. So here, right, Altair can work with this pretty easily, right? And we're actually using the lookup. So here, right, we're going to actually join the unemployment rate to the mark geotype. So here it's actually doing a lookup by ID. So one of the tricks here is that, of course, it makes it really handy that the ID for each, in this case, I think each county matches. It has to match between the county's data set and the unemployment data. Here, right, the unemployment data is passed as a URL, right? We're not passing the full data set. Yeah, that's really it. We can specify different projections, right? And we specified our encoding. The transform lookup here is where we went and joined the different data types. So if you're familiar with building out these types of graph before, this is a really handy way to go ahead and build them out. Here's a few more. These are examples from Jake Vanderplas. He built Altair on top of these other technologies. In addition to MPL D3, he's built a lot of these different tools for people doing statistical visualization. Okay, so to see where this lives, right, D3 is the go-to viz library. You ask people, like, what is the hot visualization language? D3, right? And of course, we cover D3 here. But, building a chart in D3 can be hard. So here's just an example D3 chart. I think this one is from the New York Times. It's really cool, right? They've used a lot of different encodings. It's maybe not like a type of graph you've seen before explicitly. And yeah, this is a graph you might want to build. It's really hard to build this in D3, right? This might be a couple months long project to go and build a graph this complex in D3 out of the box. Right, working with it can be hard. So as an example, right, here's a bar chart in D3. Right, D3 is really in this case just a drawing library, right? All it's going to do is draw stuff onto an SVG. In this case, I think an SVG, yeah. And this is all the code that we needed to build a bar chart, right? That's quite long. You might want to use D3 if you're going to build out the same bar chart every time. For Vega, right? Vega actually I think ends up being a little bit longer. It's a declarative spec built on top of D3, right? We included the data here as well, right? But Vega is going to sit on top of D3 and allow you to specify the data, the encodings that you want to do. So it's declarative, right? But it's very low level declarative. So you specify the scales and you have to give it everything that it needs. It's pretty verbose. So on top of that is Vega Lite. So Vega Lite will assume a lot of things that you don't specify inside of Vega. It's simpler, right? And here this actually begins to look a lot like we saw in Altair, right? And again, Altair sits right on top of this. So you could see how this same chart would be built in Altair. There's the data, and there's our chart, right? Our chart is a quote-unquote one-liner. It'd be easy to stuff this, I think, under 80 characters and one line from the chart.data, or the chart of data. And that's what Altair gives us, right? So it lives right on top of these other frameworks. It will spit out the Vega Lite spec. The Vega Lite spec compiles down into Vega, and then that gets rendered on D3. So all this happens when you go ahead and call chart, right? Then it will actually generate the HTML, and then it all goes out through the JavaScript. So that's what Altair gives us. At the end of the day, we have a declarative library for doing data visualization, and we can get to making really cool visuals.